The bell rings in 12 minutes. And Ms. Lena Hartman is still staring at a blank slide. The projector hums. 28 ninth graders are about to walk in. Today's topic, climate feedback loops, is the one she promised would finally make sense. But her notes are scattered across 3 documents, her examples feel flat, and if this lesson collapses, she'll lose them for the entire unit. You know that feeling. When you've mastered the subject, but explaining it clearly, visually, memorably, that's the part that keeps you up at night. Lena has been teaching science for 11 years. She's organized. She cares. She stays late more often than she admits. But today is packed. First period, climate systems. Third period, a surprise evaluation from the principal. After lunch, a parent meeting about a struggling student. And by the end of this video, you'll see how one simple tool helps her turn messy ideas into clear visuals, structured explanations, and better class engagement, without adding more hours to her day. And the moment that almost derailed her first lesson? That comes back near the end. Welcome to Everyday AI. Here we focus on how everyday people use AI to make work easier, life simpler, and problems less stressful. No hype, no buzzwords, just practical AI tools explained in a way anyone can understand and use. It starts with clarity. Climate feedback loops are abstract. Ice melts, albedo changes, temperatures rise, permafrost releases methane. It's all connected. But when Lena explains it verbally, students nod and then freeze when asked to draw it. Last week, half the class mixed up cause and effect arrows on a quiz. She knows what that means. If they don't see the structure, they won't retain it. She glances at the clock. 9 minutes. She could draw something quickly in PowerPoint. Boxes, arrows, hope for the best. But rushed diagrams create new confusion, and confusion spreads fast in a classroom. She opens her browser and types, Napkin AI. The interface is simple, a blank canvas, a prompt box. She pastes her rough explanation. Explain the positive ice-albedo feedback loop in simple steps for 9th grade students. Within seconds, structured text appears. Short bullet steps. Clear cause to effect progression. But she needs more visuals than texts. Firstly, she explains Napkin AI, what she exactly wants. Then she just clicks on Generate Visuals and selects her choice of diagram. Napkin transforms the steps into a clean concept flow. It's simple, clear, minimal. Total time invested, 3 minutes. Before, she would have spent at least 20 manually aligning shapes. She exports the visual as an image and drops it into her slide. When the bell rings, she's no longer improvising. But clarity creates a new challenge, because once students understand the diagram, they start asking deeper questions. Third period. The principal sits in the back with a tablet. Lena moves to a new example, methane release from permafrost. A student raises his hand. So is that also a feedback loop or just a one-time effect? Another chimes in. Wait, what's the difference between positive feedback and something just getting worse? She feels it, that thin line between momentum and confusion. If she answers too vaguely, they disengage. If she overcomplicates it, she loses half the room. And the principal is still typing notes. So, during a short group activity, she opens Napkin AI again. Create a simple comparison between positive feedback loops and negative feedback loops in climate systems. Include one clear example of each, suitable for a 14-year-old audience. The output appears structured. Positive feedback loop. Amplifies change. Example, melting ice. Negative feedback loop. Reduces or stabilizes change. Example, plant growth. Then she selects Turn into Visual Comparison. Napkin generates a clean 2-column layout. Left side, positive feedback. Right side, negative feedback. Minimal text, clear arrows. She rotates the laptop toward the projector. Let's compare these. That moment matters, because misunderstanding vocabulary has derailed entire units before. But the hardest part of Lena's day hasn't happened yet. After lunch, she sits across from a parent. Mrs. Demir looks worried. "My daughter studies," she says, "but she says everything feels disconnected. She memorizes but doesn't understand." Lena knows the student. Hardworking, quiet, overwhelmed. The issue isn't effort, it's structure. But explaining conceptual mapping in a parent meeting without sounding abstract? That's delicate. And Lena doesn't want to promise solutions she can't deliver. So, before the meeting, she had prepared something. Using Napkin AI that morning, she typed, "Turn the topic climate systems and feedback loops into a simple visual learning map showing main concept, subtopics, and how they connect. Keep it clean and printable." Napkin generated a central node, climate system, branches extended, feedback loops, greenhouse effect, ocean currents, ice and albedo. She printed it and placed the visual on the table. "This," she says, "is how we're structuring the unit." Mrs. Demir studies it. "So she can see how everything connects?" "Yes, instead of memorizing isolated facts." The difference is subtle, but powerful. Before, Lena would have tried to sketch this by hand. It would have taken 40 minutes after school. Instead, preparation took under 5. More importantly, the student now has a map, not just notes. At 4 p.m., Lena closes her classroom door. No chaotic whiteboard, no unfinished diagrams, no lingering doubt about whether they understood. Napkin AI didn't teach for her. It simply helped her think clearly, faster. That evening, she opens her laptop again and shapes tomorrow's lesson before it turns into pressure. Another bell will ring, another class will walk in, another complex idea will need clarity. And this time, she won't start from blank. If you're a teacher, you know that feeling. The question is, what would your next lesson look like if clarity came first? Comment down below and like the video if you enjoyed Lena's story. See you in the next video!